Hello everyone, today we will be discussing the remaining problems of exercise 6.6. The first question which we are dealing with is question number 5. In the figure, AD is a median of a triangle ABC and AM is perpendicular to BC. Prove that first subdivision is AC square is equal to AD square plus BC into DM plus BC by 2 the whole square. Second subdivision is AB square is equal to AD square minus BC into DM plus BC by 2 the whole square, and third one is AC square plus AB square is equal to 2AD square plus half BC square. So let's start with the first subdivision. For that we are considering the triangle AMC, which is again right angled at M. So in triangle AMC, which is right angled, so you are just using by Pythagoras theorem, you will get AC square is equal to AM square plus plus MC square. Now we want in terms of BC. Okay, so what we are doing is we are keeping AM square as such and replacing MC with, this is your MC. MC can be replaced with MD plus DC. MD plus DC the whole square. Now again what we are doing is, since AD is acting as the median, of the triangle, that means BD will be equal to DC and both will be equal to half of BC. So we are just replacing BC with half BC because we need in the answer BC by 2. So this will become AM square plus MD plus half BC whole square. Okay, since DC is equal to half of BC. And now we are just expanding using A plus B the whole square. You will get AM square plus MD square plus half BC the whole square plus 2 times of MD into half BC. 2 get cancelled. This will become AM square plus MD square plus, this is your BC by 2 the whole square plus MD into BC. Now when you see the first part, you have this term, then you have BC into DM also. So these two terms, AM square, these two terms should be replaced with AD square. Is it possible? Just see the figure. If you consider the triangle AMD, you will have AM square plus MD square is equal to AD square. So AM square plus MD square can be replaced with AD square. So you are just getting the answer as AD square plus BC into MD plus BC by 2 the whole square. And the reason for this is, since triangle AMD is right angled, therefore AD square is equal to AM square plus MD square. Okay, so you got AC square is equal to, first option is okay. Now going for the second subdivision, you have AB square is equal to, so we will consider the triangle in which you have that as your hypotenuse. So ABM can be considered. So in subdivision second, you will start with triangle AMB. Again it is right angled, so you can use your Pythagoras theorem and you will get AB square is equal to AM square plus MB square. AM square plus MB square. Now we will be replacing MB. Now this is MB, means you can just rewrite it as BD minus MD. Okay, BD minus MD the whole square. Now expanding this with A minus B the whole square, you will get AM square plus BD square. Again what we will do is we will just replace BD with half BC also. Okay, so first I am just replacing it with half BC and MD is as such whole square. Now using the concept of A minus B the whole square, you will get BC by 2 the whole square plus MD square minus 2 into BC by 2 into MD. So that this is your AM square. I'm just writing this first, MD square plus BC by 2 the whole square minus BC into MD. Again, in your answer you should get AD. So we are just replacing these two. Go for the triangle AMD. You will get AM square plus MD square is equal to AD square. So this is equal to AD square plus BC by 2 the whole square minus BC into MD. Reasons are all same. Here you have triangle AMD is right angled. So you will have AD square is equal to AM square plus MD square. Okay, and here you have used BD is equal to half BC. Clear? And for the third subdivision, you can just see your LHS for the third subdivision is AC square and AB square summed together. So we are just adding first and second subdivisions. That is, we have AC square is equal to AD square plus BC into DM plus BC by 2 the whole square, and AB square is equal to AD square minus BC into DM plus BC by 2 the whole square. Okay, so these two equations we are adding, first one and second one. So adding 1 and 2, we will have the left hand side as AC square plus AB square, and the right hand side will give you this much 2AD square, and these two will get cancelled. Here you will have 2 times of BC by 2 the whole square. That means 2AD square minus 2 into BC square by 4, or you will get 2AD square minus BC square by 2, or half BC square, which is your AC square plus AB square. Okay. Question number 6 is, prove that the sum of the squares of the diagonals of parallelogram is equal to the sum of the squares of its sides. So I have taken a parallelogram ABCD and the diagonals as AC and BD intersecting at O. Okay, so the diagonals bisect each other. That means this length BO will be equal to OD and AO will be equal to OC, right? Now what we have to prove from the figure is to prove that sum of the squares of the diagonals, here the diagonals are AC and BD. So the sum of the squares means AC square plus BD square is equal to the sum of the squares of its sides. Its sides are AB, BC, CD and DA. So we'll get sum of the squares of its sides means AB square plus BC square plus CD square plus DA square. This is what you need to prove. Now, in order to prove this concept, what we are doing is we are going to the result which we have already proved in 5th question's third subdivision. And what was that? If you are considering a triangle with a median also given, we can say that one side square plus another side square is equal to, that is in this figure, if I take ABC, I will say AB square plus BC square is equal to 2 times of the median square plus half the third side square. So that is the result which we are using here for this triangle as well as this triangle, and then adding the two will give you this result. Okay. So let's start with that is, consider the triangle ABC. In triangle ABC, we know that BO is acting as the median. BO is the median. So by that result, what we will get is AB square plus BC square. AB square plus BC square is equal to 2 times of BO square plus half of AC square. Okay, and this is from your 5th question's third subdivision for your reference I am writing. Okay, now again I am taking another triangle, that is the other one. Here DO or OD is the median. Okay, so in triangle ADC, DO is the median. And applying the same result as above, we will get AD square plus DC square. AD square plus DC square is equal to how much? 2 times of DO square plus half of AC square. This is also by the same result. Okay, so let it be equation number 1 and this be equation number 2, and we are adding. Now why we are adding? You just see the right hand side of what is to be proved. AB square plus BC square plus AD square plus CD square. Okay, so adding 1 and 2, we will get AB square plus BC square plus AD square plus DC square is equal to 2BO square plus 2DO square plus half AC square plus half AC square. Here you can just take out the 2. BO square plus DO square, and half plus half of the same will give you 1, which is AC square. Now what we are doing is, from the result you can see you have got AC square. Now you need to get BD square. So in terms of BD, we will write both BO and DO. And again we know that BO is half of BD and OD is also half of BD. So we are just replacing BO and DO with half of BD. Okay, so half BD whole square plus half BD whole square plus AC square. So this will give you 1 by 4 of BD square plus 1 by 4 BD square plus AC square. 1 by 4 plus 1 by 4 will give you half. So it is 2 times of half of BD square plus AC square. These two get cancelled and you are getting BD square plus AC square, which are the diagonals. You just see BD and AC. So BD square plus AC square. From where you have started? AB square plus BC square plus AD square plus DC square is equal to BD square plus AC square. Hence, we have proved. Question number 7. In figure, two chords AB and CD intersect each other at P. Prove that triangle APC, this triangle, and triangle DPB, these two triangles are similar, you need to prove. And the second part is AP into PB is equal to CP into DP. Okay, so first we will go for the first subdivision, and for that what we are considering is we are getting two pairs of angles equal. So we can apply AA similarity in order to get the similarity between the two triangles. Which are they? First you can see this angle will be equal to this. Why? Because they are vertically opposite angles. So first thing which we are getting for the triangles is angle APC is equal to angle DPB. They are vertically opposite angles, so they are equal. Okay, next thing is this angle will be equal to this angle. Why? Because if I have this thing like I have two segments, this side and this one. So these two angles, that means angle CAB and angle CDB, if you consider, they are lying on the same segment and the angles on the same segment will be equal in measure. So I can say that CAP is equal to, okay, CAP is equal to angle BDP. Angles in the same segment. Are equal, therefore. Okay, so you have got two pairs of angles to be equal. Hence you can say that by AA similarity, triangle APC is similar to triangle DPB. Okay, APC is similar to triangle TPC. This is your first part. Now for the second part, you can use the concept of first part, that is a similarity concept, and since the two triangles are similar, their corresponding sides will be proportional. So we are just saying that since triangle APC is similar to triangle DPB, we have the corresponding sides which we need is AP is there, so we'll take AP by DP. AP by DP is equal to, again you can just see you have PC, so you can take PC and PB. Okay, PC by PB. Now cross multiplying, what you will get, AP into PB is equal to DP into PC, which is what you need. PC same as CP, so this is a thing in it. Okay, this is since the sides are corresponding sides are proportional, for similar triangles. Okay, this is the reason. Clear? Question number 8 is, in figure, two chords AB and CD of a circle intersect each other at a point P when produced outside the circle. So you have AB and CD, two chords of the circle, and they have been produced to meet somewhere at P, which is outside the circle. Now you have to show that triangle PAC is similar to triangle PDB. PAC is the smaller one, is similar to this bigger one, PDB. Okay, and from that you will be following this result also. So first we will start with subdivision 1. Here you will get this angle to be common for both the triangles, right? So we are writing angle P is common. So how we will write it as is CPA is equal to angle CPA is equal to angle BPD. Okay, CPA is equal to BPD, and the reason is common angle. Then one more you have to get, and for that concept we are using, since ABCD is forming a cyclic quadrilateral, you can say that for a cyclic quadrilateral we have the result that this is acting as an exterior angle for the cyclic quadrilateral, right? And exterior angle will be equal to the opposite interior angle. So the opposite interior angle is this angle B. So you can say that these two angles will be equal. Okay. So the second thing which you are getting is ACP is equal to angle DBP. Okay. ACP is equal to angle DBP, and what is the reason? Since in a cyclic quadrilateral, exterior angle is equal to opposite interior angle. So from the two concepts you can say that by AA similarity, triangle PAC is similar to triangle PDB. Now for the second part we will use the first part, which is since triangle PAC is similar to triangle PDB, what you can say, the corresponding sides will be proportional. And what are the corresponding sides we are taking? We need PA, PB, PC, PD. So if I am taking PA, here it will be PD. So PA by PD is equal to, again we need PC. So here PC by PB. It will give you PA into PB is equal to PC into PD. And the reason is the corresponding sides are proportional for similar triangles. Okay. Question number 9 is, in the figure, D is a point on side BC of triangle ABC such that BD by CD is equal to AB by AC, and you have to prove that AD is the bisector of angle BAC. Angle BAC is this angle. AD is acting as the bisector, means you have to show that this angle is equal to this angle. That means your ultimate aim is to prove that angle BAD is equal to, that is this angle is equal to this angle, which is your angle ADC. Sorry, DAC. Okay, this is what you need to prove. Angle BAD is equal to DAC. So for that, first what we are doing is, in the figure only this much is given. What we are doing is, we are just extending BA to meet at E so that AC is equal to AE. So this length equal to this length we are taking, and we are joining EC. Okay, so that is your construction part. What we are doing? Extend BA to meet at E such that AC is equal to AE, and then join E and C. Okay, this much you have constructed. Now what we are doing is, first thing we have to take what is given in the question, that is your on fractions equality is given, that is given BD by CD is equal to AB by AC. And after this, what you are doing is, since you have taken AC to be equal to AE, we are replacing AC with AE. Okay, so this will give you BD by CD is equal to AB by AE. Now go to the figure and see, BD by DC is equal to AB by AE. So this will give you an idea about the converse of BPT, because if you have this fraction, this proportionality, you can say that these two lines are parallel by the converse of BPT, and this will imply that AD is parallel to EC. What is the reason? By the converse of BPT. Okay, so this much you got. Now using that parallelism concept, what we will get is, this angle will be equal to this one. How? Because this is acting as a transversal, and these are alternate interior angles for the two parallel lines AD and EC. Okay, so first thing which we have from this concept is, angle DAC will be equal to angle ACE. Reason is alternate interior angles. Okay, the other thing which you will get is, just see, you will get BAD, that is this angle is equal to this angle. How? Because they are corresponding angles. Okay, so angle BAD is equal to angle AEC, and the reason is corresponding angles. One more thing which we will get is the concept which we will get these two equations, and then we will have ACE is equal to AEC. How? Because we have taken in the construction as AC is equal to AE. So for the this triangle ACE, you will get this side equal to this side, means their opposite angles will be equal. So we are getting this angle equal to this angle. Okay, since AE is equal to AC. By construction, you will have angle AEC is equal to angle ACE. And looking at these three equalities, you can see that AEC equal to ACE means these two are equal. And from these two, you will get these two to be equal. Therefore, from the above three equations, we get angle DAC is equal to angle BAD. Just go to the figure. DAC, this angle is equal to angle BAD. That is what we need to prove. We have already written angle BAD is equal to angle DAC is our ultimate purpose to prove. And since we got this, we can say that AD is the bisector of angle BAC. Okay. Question number 10 is, Nazima is fly fishing in a stream. The tip of her fishing rod is 1.8 meter above the surface of the water, and the fly at the end of the string rests on the water 3.6 meter away and 2.4 meter from a point directly under the tip of the rod. So we have drawn a rough figure. The figure is given in the textbook. You can just see she's sitting here, and from here the string starts. This is the rod which she has on her hand, and this is the string, and they are saying that she is above the surface 1.8 meter and it rests on the water 3.6. Okay, so the total thing, you will have 3.6 meter away, and from the point the string starts, you have 2.4 meter. Okay, directly under the tip of the rod, you have this much as 2.4. Okay, now assuming that her string, that is from the tip of her rod to the fly, is taut. Is taut means it is tight, stretched. Okay, tightly stretched. Then that is it is straight. You can consider it as a straight line. That's what they are giving. How much string does she have out? So how much is out means you have to find out from the figure. If I say you have to find out this length AC. Okay. Now if she pulls in the string at the rate of 5 centimeter per second, that is at this speed, she is just pulling inside towards her side this string. At that time, the length of the string will be decreasing. Okay, and they are asking what will the horizontal distance of the fly from her after 12 seconds. That means the time is also given. So from this speed and time concept, you can find out the distance. Okay, so that will give you this distance. Clear? So first what we are doing is we are considering the triangle. Here again it is right angle triangle. So we are considering ABC. Triangle ABC. So consider triangle ABC. So first concept is to find out what is AC. Okay. Then what we will do is we will find out the new length or the remaining length, if you say. That also we will find out. That is AD also we will find out. And then our purpose is to find out this horizontal distance of the fly, means this distance when the string has been pulled towards her, it is reaching at some point, and that is taken as D, and this distance plus this distance will be the horizontal distance. Okay, that will be your last answer, second subdivision of the question. So first we are considering triangle ABC, which is again right angle triangle. So you are using Pythagoras theorem there. You will get AC square is equal to AB square plus BC square. Now, so AB is given to be 1.8 meters. So a 1.8 the whole square plus BC is given to be 2.4 whole square, and this will give you how much? It is 18 square is 324. So this will be 3.24 plus 24 square is 576. So it is 5.76. which is equal to how much you will get here. You just see 4, 10, 0 and 1, 8, 9, 10, 0, then 9. So you are having AC square as 9 meters, or you can say AC is equal to 3 meters. Okay, so first subdivision is over. That is, you have found out the length of the string which is out, that is 3 meter. Now the new length of the fly, that is when the rate of the at which rate it has been pulled in, that is given, and the time is also given. So we will find out that distance. Okay, so the length of the string, or you can say the new length of the fly, which if you take, it is acting as the distance. Okay, distance is equal to what? Speed into time. So there you will get speed is 5 into time in seconds. Okay, the speed per second, and 12 is given. 5 into 12, but here 5 is given in centimeters and remaining all are in meters. So what you need to do is, it is 5 by 100 meter. Okay, 5 by 100 will give you 0.05 into 12, or you can say it is 60 with, okay, 0.6 meter. So this will be the new length of the fly. So what we have to find out now is the remaining length of the fly. Remaining length. How will you get the remaining length? You have to subtract it from the original length. Okay, so from the original length means it is AC, which is 3. 3 minus 0.6 will give you 2.4 meter. So that is your new length, or you can say remaining length of the string when it has been pulled inside. So this is your 2.4 which you got, and this is your 3, right? Got it? And okay, you can just keep it as this is your AD. Okay, now we are just considering the another triangle, that is right angled triangle, which is your ABD. Why? In order to find out this distance, because the horizontal distance which we need to find out is this one. For that we need what is this length. Okay, so we are considering triangle ABD. In triangle ABD, again you have AD square is equal to AB square plus BD square, and what you need? BD square. Remaining 2 you have the values. So BD square is equal to AD square minus AB square. Replace the values of both. What is AD? You have got it to be 2.4. So it is 2.4 the whole square minus what is AB? 1.8 the whole square. Okay. So what you are getting here is, it is 5.76 minus 3.24. 5.76 minus 3.24, and which you are getting it to be 2.52. You see, 2.52 meters. And this is actually your BD square, and you need to find out what is BD. That means you have to find out the square root of 2.52. I'll just show it here. The square root of 2.52, like this you are taking, or you can just make a bar like so. 1 here, 152, again 2 together, and 1, this will give you like this. And since point is here, 2 point it is, so here you will have a point. Then you have to just take a number here as well as here, so that, so I have got 5 here, so that 25 into 5 will give you 125. Right here 125. Then subtracting, you are getting, how much you will get here? 7, then 2. Okay, 27. Now putting 2 zeros here, and the purpose here, what will we do? 15 into 2 will be written here, and you have to find a number, so that you are writing the same number here. Multiplying, I am getting 8 to be an apt number, so I am just replacing here with 8 as well as here with 8. and 308 into 8 is giving you 2464. Then again, when you do 158 into what you need into 2 will give you 306, and one more number you have to write, and this after subtraction is giving you how much you are getting. 6 here from 10, you are replacing it 3, and this will give you 2. Okay, so like this you will get. Then you have to again find a number. It will be somewhat like above 8, or okay, 7 will be okay. So you'll get 7 here, 7 here, and the next number will be 3067 into 7, which you will get it to be 21464. 21464. Like that it will go. So we need somewhat here. You can just take approximate value of this, which is 1.59 you can take. So from here you are getting BD is equal to root of 2.52, which is approximately equal to 1.59 meters. Okay, so 587 I have made it as 59 approximately. And what is the last thing? You have to find out the horizontal distance. Therefore, the horizontal distance of the fly is equal to, it will be BD together with this distance. Okay, 1.2, which is already given in the question. So that will give you 1.59 plus 1.2. How much you will get here? 2.79. 2.79, and this is also approximate because here we have taken the approximate value, so the answer which you are getting is also approximate. 2.79 meter is the horizontal distance. Okay.